Back to Data Science on the Fly. So in today's tutorial, we're going to be talking about how to use the group by. So I'll change the title here to Demo using Pandas group by method. This is a really powerful method, and for those who have some exposure to SQL, this is very similar to how SQL group by works. So we'll just get into it and talk about it as we're working on it, so you can have a visual understanding of what's going on. So before we get into any of that, we want to import the important libraries. So in this case, there's just one. I know we're not going to be working with NumPy for this tutorial, but I do know we're going to be working with a data frame. And because of that, I'm going to import pandas as PD because we need this one. For data frames. All right, run the cell. And then from there, the first thing I'm going to do with the pandas library is use a method read underscore CSV to bring in my data frame. So df equals pd dot read underscore CSV to bring in my data frame. And if you remember this method here, read underscore CSV, it takes an argument, and the argument is the file path for that CSV file. Mine is going to be where it lives on my computer. Yours is going to be different. It depends on where it lives on your computer. And remember that the file path goes in quotations. So my file path is what I'm using. All right. And then the first thing I'm going to do is check the rows and columns of this data frame. All right. So df.shape gives me back 1,871 rows and 16 columns. Next thing I'm going to do is use my df.columns method as an argument to my list method to take a look at what those columns are. We've got ID, admitted, test, AP, average AP, all of these below. So if you look here at the CSV file name, you'll see that I'm actually working with college admissions data. And this data set has 16 columns, all related to college admissions, and it appears to be at the student ID level. So for every ID of an applicant, these features are captured, whether or not they were admitted, test, AP. Now, I'll reiterate that in the best case scenario, you have a data dictionary, and a data dictionary tells you explicitly what each of these features means. And even better, data dictionaries tell you exactly how the features are calculated, because sometimes definitions can vary. But the more specific and precise a data dictionary, the better it is for a data scientist to work with, because the data scientist isn't unclear on what different features mean. In this case, I don't have a data dictionary for college admissions data. I think the features are pretty obvious and that we can work with them. So let's continue. The next thing is I'm going to look at the first few rows of the data frame using df.head. Great. Looks good. All right. Looks like the admitted column is ones and zeros, and looks like the other columns, the data types for them range. Some of them look like floats, some of them look like Boolean, some of them look like strings. So I can just use df.dtypes, and dtypes returns the data type of each column, of each feature in a data frame. So this is a really useful one. Yep, and it tells me that for admitted, it's integer, and then for average underscore AP, it's float. And then whenever you see this object here, this object data type for a pandas data frame, often it's a string. Sometimes date or timestamps are also stored as object data types. Okay, so from here, let's actually get into it. So the first thing I want to do is I'm looking at this college admissions data set here. And I see that admitted, I see a lot of ones here. So first thing I'm going to do is I'm going to check what are the possible values for admitted. So one quick way I can do that is df.admitted.unique. And this goes to my data frame, This says only get me back values for the admitted column. And this says only get me back the unique values for the admitted column. All right, I've got 1 and 0, so this is Boolean. And I think it's a fair assumption that 1 is students who were admitted to their university and 0 students who were not. So I think it's fair to say 1 is equal to true and 0 is equal to false. So from here, what if I want to see what the count was for admitted students versus not admitted students? Well, that's where groupby can be really useful, because what groupby does is you pass it a feature that you want to group rows by. So group the rows in this data set by. And then for each of those groups, you can use a function to calculate something for that group. So in this case, if I start off with df.group by, I need to say, what do I want to group by? Well, I want to group by admitted because I want to know how many were not admitted and how many were admitted. So I want to group by admitted. And then from there, I want to know the count. And here, I'm really looking for the count of IDs for each of those categories. Count of IDs in the 1 admitted category, which means those students were admitted, and count of IDs in the 0 because those students were not admitted. But if I just use this syntax here, if I just leave it here, here's what I get back. I get back the counts of all the rows for which admitted is 0 and the counts of all the rows for which admitted is 1. And that's fine, I guess, but really, we're looking for this one. So what I want to actually do is say, all right, just give me back ID. Just give me back the counts here and here. Great. So now I see that out of the entire data frame, there are 1,366 IDs with a 0 admitted value and 505 IDs with a 1 admitted value. So at this point, I should have done this check earlier. Generally, I do this check earlier, but I just want to stop for a second and check for how many null values there are in my data frame. So I do df.isNA.sum. And this is a really, really useful chained set of methods because it returns the number of nulls for each feature in my data frame. So there's 16 features in my data frame, and for each of those features, it's going to return the number of null rows for that feature. And it looks like all of my values for admitted are filled out. There are some nulls in program, and this seems to be add info, which I'm interpreting as additional info. But for admitted, I don't have any null values. So that means that out of the entire data frame, 1366 students were not admitted and 505 were admitted, and that's all the data we have. So what I like to do is often I will create a data frame using groupby. And to really create that data frame, I have to use this other command here, reset index, this method. And what this does, it's very powerful and useful. What this does is it takes all of this, and the result of this line here is right here, and it just gives me a neat and clean data frame. So now I have this smaller data frame here, and I can assign this whole line to a variable, and then run it like that, and this is now that grouped by data frame, grouped by admitted, only including the counts of the IDs in this very clean format that I got by using reset index. Okay, so what if I want to use groupby again, but I want to do something else with it? All right, let's try another example. What if I want to see the difference between the students who were admitted and not admitted, but not in terms of their counts, but instead in terms of their average GPA. Is there a difference between the average GPA of a student who's not admitted versus who is? So to do that, I again go back to my data frame, and this time again, I'm looking for differences between students who were and weren't admitted. So I'm grouping by admitted once again. df.groupby equals admitted. But this time, I don't want to use the count like I did up here. I actually want to use mean because I want the average. And what do I want the average of? Specifically, I want the average of the GPA. So I'm going to specify that, and then let's see what we get. Here we go. So for students who were not admitted, average GPA is 3.87. And for students who were admitted, average GPA is 3.91. So a little higher for students who were admitted. And if I want this to look cleaner and look like a data frame, I can use reset index again, just here. And then I run that, and here we go. And then just like we did earlier, I can assign this whole line to a variable. And now that variable contains this new data frame that I've made. Small, but it's still a data frame. Okay, let's see if I can do the same thing, but this time I want to look at mean test score. Looks like these are SAT tests, mean test score. So again, df.groupby, and I'm looking for the difference in between the students who were admitted and students who weren't. So again, I'm grouping by admitted because that's the feature that captures this distinction. By equals admitted, and then I'm looking for differences in the average, but this time test. And I'm going to just go ahead and do reset index here because we know how it works now. So here we go. The average test score for admitted students was 2165, and the average test score for unadmitted students was 2165, and the average test score for admitted students was 2245. So a bit higher for admitted students. Okay, well, what if I want to see the average number of AP classes they took, which I believe is captured in this variable here, AP. I think this is AP classes. So again, what are we grouping by? We're grouping by admitted because one group is students who were not admitted to their university and one group is students who were admitted to their university. So df.groupby equals admitted. That's what we're grouping by. Again, we want to see the mean, so we use mean. And then what do we want the mean of? We want the mean of the AP classes. And then reset index is just a nice way to make these results here look like a data frame. There we go. So the average number of AP classes for not admitted students, 3.4, and for admitted students, 3.6. This doesn't really tell me that much, I don't think, because again, with average number of classes, we're not seeing a striking difference. And if we really wanted to understand what are the most important distinctions between students who are admitted to their university versus not admitted, we want to see a big difference in each of these variables. So out of all of these, I would say probably the most striking difference to me is in test, because we see that for students who are admitted to the university they applied to, they have an average test score of 2245 versus not 2165. It's about like 80-point difference, I think. So that might be something. 3.87 compared to 3.91. I don't know, it doesn't really seem that different to me, but really when you get up there with high performing students, even just like the most minute differences do tend to matter. So what all of this would indicate to me as part of my exploratory data analysis is that I need to keep exploring to find out, to surface what are the really most important features when it comes to whether or not a student is admitted or not admitted. All right, so, and we don't just have to use count and mean. So this is how you can use group by to group by a certain feature in your data frame. This is going to be a categorical feature, so a feature that has just a small subset of values. And you can use groupby to help you understand or begin to understand what are the differences between the values for that categorical feature. So in this example for admitted, what are the mean GPA differences? What are the mean test differences? What are the mean count of students differences in that categorical variable that you're paying attention to? And this is all part of exploratory data analysis and understanding what's happening in the data and surfacing key insights. Now, sometimes you might use groupby and you might discover that you need to do more data analysis. This is an example of that. I don't think that this particular small exercise surfaced anything that was really astounding, like, oh, look, the mean GPAs between admitted and not admitted are dramatically different. So GPA is super important when it comes to admission into university. None of that, I think, was quite obviously the case. Sometimes it will be, and that's great, and sometimes it's not, and that whatever happens, that's what informs the rest of your exploratory data analysis journey. All right, so I'm going to stop here for today. I hope this was useful. So just a summary, we used the college admissions data set, and from there we applied groupby, and we grouped by the values in the admitted feature, and admitted was a Boolean, so it had 1 and 0, 0 being false, the student was not admitted, 1 being true, the student was admitted. And then for admitted, we looked at the count. We applied the count method to see how many students were in each category for admitted. And then from there, we checked out how we can use mean to find the averages. We may not always want to use mean. We could use min, max. There are a variety of functions and they're well documented. So I would definitely recommend go check out what methods are available for you to group by in pandas in Python, because that'll be really helpful and you can certainly add that to your toolkit. And then I'll just underscore that dot reset underscore index. This has been an incredibly useful method for me in my work, because it just takes the results of this and creates a really, really visually helpful, simple data frame based off of them. And then once you have a data frame, then you can use methods on that data frame, which makes everything so much easier. All right, until next time.